Hello students. In this video session, we are going to study about the classification of organic compounds. Organic compounds are classified based on their structure as well as their functional group. So in this video, we are going to study about how these organic compounds are classified based on their structure. Based on structure means based on that carbon skeleton. Organic compounds are mainly classified into the two class, open chain compound and ring compounds. So open chain compounds, these are also called as aliphatic or acyclic compounds. In this structure, all the carbon atoms are linked to each other and they form open chain structure. For the cyclic or ring, all the carbon atoms are in the form of ring. Ring compounds are further classified into the homocyclic and heterocyclic depending upon that same group, same carbon atoms or that other than carbon is present in the ring. And they are further classified into the aliphatic compound and aromatic compounds. Heterocyclics are also classified into the alicyclic and aromatic compounds. So now see the first classified group, important branch of this organic chemistry is aliphatic. These are also called as acyclic or open chain compounds. Aliphatic compounds are the compounds in which carbon atoms are joined to form an open chain. The structure may be contain straight chain or branch chain. They are further classified into the saturated and unsaturated compounds, in which alkanes are saturated, whereas alkene and alkynes are unsaturated. See, these are the examples for alkane, which are aliphatic saturated hydrocarbons, means in which carbon atoms are linked to each other and what they form here, open chain structure, though it is in the branched form, but it is a open chain structure. See, the first example is in which the 6 carbon atoms are in chain, therefore its name is hexane. Here, see 1, 2, 3, 4, 5. 5 carbon atoms are in a straight chain and one methyl group is as a branch group and which is present on the second carbon atom. So 2 methyl pentane, here 3 methyl pentane. Okay, in these structures here, these 5 carbon atoms are in chain and the branch group, methyl group are present on the carbon number 2 and 3 and therefore 2, 3 dimethyl pentane, or what you can see here, carbon number 1 and 2, 2 dimethyl butane, as in this chain 4 carbon atom. So all these examples are for the alkanes, which are aliphatic saturated hydrocarbons. In their structure they contain only carbon-carbon single bond. Second is for the alkenes, which are aliphatic unsaturated hydrocarbons, in which carbons are bonded with the double bond. Okay. At least one carbon atom is present in their structure which contain double bond, or more than one time a double bond is also present in the alkene. Ethene is the first member of the alkene. Propene, okay, which contain 3 carbon atom and double bond. See, these are the 4 carbon atom and bond is present in between carbon number 1 and 2. Therefore, but 1 ene. Here, 5 carbon atoms are in chain. Bond is present in between carbon number 1 and 2 and therefore pent 1 ene. 1 hexene. See, all these are the examples for the alkenes. Okay, examples for the alkenes. Next, for the alkynes, which contain carbon-carbon triple bond in their structure. Acetylene, which contain 2 bonds, 2 carbons with the triple bond. Okay, so it is the first member of alkyne family, acetylene, or what we can say ethyne. This is propyne. See, this is the bond line structure for the propyne. Okay, this triple bond. Okay, and what is here, CH3 and C and here CH. So this is the 1, 2, 3, 4. Okay, so 1 butane, 2 butane. These are the examples, or 2 hexane, where in the between carbon number 2 and 3 triple bond is present and in chain 6 carbon atom. Therefore 2 hexane, 3 hexane. All these are the examples for the alkynes, which contain triple bond in their structure. So alkane, alkene, alkyne, these are under the class of aliphatic compounds or open chain compounds. In the cyclic compounds, these are the compound in which carbon atoms are joined to form one or more ring with or without heteroatom. Okay, so according to the presence of heteroatoms, they are classified into the homocyclic and heterocyclic compounds. Homocyclic compounds in which the ring is made up of only carbon atom, means they are joined to each other in the ring form, but in the ring all these carbon atoms are present here other than one carbon atom is present in the ring. According to that, they are classified into the homocyclic and heterocyclic. These homocyclic compounds are also called as carbocyclic compounds. In this homocyclic, the ring is made up of carbon atom only, and according to that, they are classified into the alicyclic compounds and aromatic compounds. Means now see here, these are the alicyclic compounds. Now the alicyclic compounds are those which shows the similar properties to that of the aliphatic compound. Aliphatic compound means alkane, alkene and alkyne. Okay, so why? Because they also contain the single bond in their structure. But these, what is the change here? These carbon atoms are linked by a single bond only and in the ring form. See, the only propane, it is example for the aliphatic compounds alkane, but cyclopropane, we have where the ring is present, and therefore it is example for the ring compounds and alicyclic compounds, and also these are the homocyclic compound. Homocyclic because the ring is made up of only carbon atom. Cyclobutane, see these four carbon atoms are in the ring form and the ring is made up of only carbon, and therefore this is example for homocyclic alicyclic compound. And homocyclic, it is a branch group of the ring compounds. Cyclopentane, cyclohexane, these are the example for alicyclic compounds. And one more thing is that see here, cyclopropane, cyclobutane, these are the bond line structure for these cyclopropane, cyclobutane. So this is about the alicyclic compounds, which is the class of the homocyclic compound. Aromatic compounds are the compounds which contain at least one benzene ring. Benzene ring means C6H6. So this is the benzene ring. Compounds which contain benzene ring, these are classified under the class of aromatic compounds. See the naphthalene, phenol, in which OH group is present on the aromatic ring, aniline, NH2 with the phenyl ring, and carboxylic acid, C6H5, C double bond OH. So all these are the examples for aromatic compounds. See here, aromatic compounds, and these are the homocyclic compounds. Ring is made up of only carbon atom only. Therefore, these are homocyclic aromatic compounds. Next class is heterocyclic compound. These are the compounds include one or more heteroatoms, means other than carbon, like oxygen, nitrogen or sulfur. They are present in the ring of in the ring form. The other than carbon is present here. In the ring of carbon atom, these different atoms are also present. They are mainly classified into the heteroalicyclic compound and heteroaromatic compounds. What are these heterocyclic compounds? Which contain one or more heteroatoms like oxygen, nitrogen, sulfur in the ring of carbon atom. So heteroalicyclic compounds are those which contain at least one heteroatom in the ring. And alicyclic means, now see, alicyclic means they not contain double bond in their structure. Therefore, these are called as alicyclic, but they are in the ring form and one heteroatom is present here. So tetrahydrofuran. This is the CH2, CH2. Here also CH2, CH2. These four carbon atoms in a ring, and with one heteroatom, this is oxygen, and therefore tetrahydrofuran. It is example for heteroalicyclic compound. Similarly, piperidine, whereas NH group is present and nitrogen is present in the ring. See, this is a ring, and instead of that, all these are the carbon, but instead of that carbon, here one heteroatom, and this is nitrogen is present in the ring. Piperidine, example for the heteroalicyclic compound. Similarly, see here these structures: ethylene oxide, ethylenamine, okay, trimethylene oxide, trimethylene, where the CH2, 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 three CH2 groups are present in the ring with one oxygen. Therefore, trimethylene oxide. These are the examples for hetero-alicyclic compounds. Hetero due to the presence of one heteroatom, alicyclic as they not contain double bond in their structure. They not contain benzene ring. Now see, these are the heteroaromatic compounds. Heteroaromatic compounds means which contain one heteroatom, but they are aromatic in nature. See, they shows the alternate double bond and single bond in their structure. Pyridine, it is an example for the aromatic compounds, heteroaromatic compound. See here, which present nitrogen in the ring. All these are the carbon and with one nitrogen, and what is here, they shows the alternate double bond and single bond, means they are aromatic in nature. Pyridine, it is an example for heteroaromatic compound. Similarly, furan, for the furan, see, this is a double bond, single bond, double bond, single bond, and what is here, on the oxygen lone pair of electrons are present, and these are considered as a bond, and therefore they shows unsaturation character, and they show these are the aromatic in nature and with one heteroatom, and therefore pyridine, furan, these are the examples for heteroaromatic compounds. Now see, this is a classification for the homocyclic compounds. Homocyclic compounds which contain only carbon atom in the ring, and as they are present in the only ring, the carbon atoms are only present, but the depending upon the type of ring, they are classified into the benzenoid compounds and non-benzenoid compounds. Means if they contain the benzene ring in their structure, these are the benzenoid. Obviously both are the aromatic compound, but only depending upon the type of ring. See how benzenoid compounds which contain benzene ring in their structure, these are the benzenoid compound, and non-benzenoid which contain an aromatic ring is aromatic but other than benzene. First we see about these benzenoid compounds which contain one benzene ring. Now see the toluene C6H5CH3, or aniline C6H5NH2, or for the benzoic acid which contain one benzene ring and C double bond OH. In all these structures they contain benzene ring, and therefore these are classified into the benzenoid compounds. And what is here, all these are the homocyclic, means the ring is made up of only carbon atom. For the non-benzenoid compounds, see here, the ring is made up of only carbon atoms, means these are the homocyclic compounds. Homocyclic compounds, but what they not contain aromatic ring in their structure, and therefore these are non-benzenoid homocyclic compounds. Tropone, which contains here 1, 2, 3, 4, 5, 6 and 7, 7-member ring, and with one ketonic group C double bond O, alternate bond character is present here. So this tropone, it is example for the non-benzenoid compound. Here tropolone, it is example for the non-benzenoid compound which contain ketonic group and as well as the hydroxy group as a functional group. Or azulene. See here, for the azulene, they not contain here aromatic ring. As one, see, this is a one 5-member ring is present here, which is attached with this 7-member ring, and therefore this is example for the which not contain benzene ring in its structure. An example for the non-benzenoid compound. But these benzenoid compounds and non-benzenoid compounds, both are the examples for the homocyclic class. Homocyclic means which contain only carbon atom in the ring, but depending upon their that benzene structure, they are classified into the benzenoid and non-benzenoid. This is for the aromatic heterocyclic. Means these heterocyclic means which contain heteroatom in their structure, and these are the aromatic, but again they are classified into the benzenoid and non-benzenoid aromatic compound. Similarly, like that what we completed here for the homocyclic. Homocyclic are also classified into the benzenoid and non-benzenoid. So this is for the heterocyclic compounds. See, benzenoid heterocyclic compounds means which contain one heteroatom in the ring, but the heteroatom is in the benzene ring. See, this is the benzene ring, this is also the benzene ring, and here one heteroatom, this is nitrogen is present, and therefore as the heteroatom is present in the benzenoid ring, this is example for the benzenoid heterocyclic compound quinoline. Its name is quinoline. Here for the azosine, it is a the ring, it is heterocyclic. As one heteroatom other than carbon is present in the ring, and ring is also not made up of by aromatic ring benzene. Okay, it is not a benzene ring, and therefore it's an example for non-benzenoid which contain one heteroatom, and therefore non-benzenoid heterocyclic compound. So this is the classification for the heterocyclic compounds and classification for the benzenoid and non-benzenoid compounds. So see here, just we see in one chart how these are classified organic compounds into the open chain or closed chain or cyclic compounds. Alkane, alkene, alkyne, example for the acyclic compounds or open chain compound. Cyclic compounds, homocyclic and heterocyclic. Homocyclic ring is made up of only carbon atom. Alicyclic and aromatic compounds. These are the two class. For the alicyclic, these acyclic compounds, open chain compounds, are in the form of ring. For the aromatic, they are classified into the benzenoid and non-benzenoid. Benzenoids which contain benzene ring in their structure. For the non-benzenoid, they not contain benzene ring in their structure. Whereas these heterocyclic compounds, they are classified into the alicyclic compounds and aromatic compounds. See, in both these structures, they contain heteroatom, therefore heterocyclic compounds, and what they having here, uh, that early cyclic compounds which not shows the aromatic character, and this pyridine it shows the aromatic character. So this is all about the classification of organic compounds which is based on their structure. Thank you.